All right, in lesson 11.2, we're going to look at the surface area of prisms and cylinders. A prism is a polyhedron with two congruent parallel faces called bases. Remember, polyhedrons, three-dimensional object. These bases here are the ones that are going to be parallel on every figure. Now those are the ones that are parallel, the bases, and the other ones are called our lateral faces. Now we name our prisms by whatever the base is. So in this case here, our bases that are parallel are pentagons. So we call this a pentagonal prism. In this polyhedron over here, we have a triangle base, which means this is a triangular prism. So if the base was an octagon, it would be an octagonal prism. An altitude of a prism is the perpendicular segment that joins the planes of the bases. The height h of a prism is the length of the altitude. So in these prisms on the left, these are right prisms because the side length, which is also one of the sides, is your height, and it's perpendicular to the bottom or the base. Remember, the height is going to be the distance between the two parallel bases. So even if it's turned on its side, these are the parallel bases here in a trapezoidal prism. So these two sides are the bases, therefore the distance between them would be the height. So it's not always the height is how tall it is, it depends on how it's oriented. And in an oblique prism, it's the distance, once again, still between the bases, how far apart they are, but in this case it would be outside of the polygon. So the first surface area problem we're going to look at is the lateral surface area. Now this may be labeled lateral surface area, or it may be lateral area, like we have here. LA stands for lateral area or lateral surface area of a prism is the sum of the areas of the lateral faces. Now we're going to use the formula here, which is going to be the perimeter of the base times the height. So P stands for the perimeter of the base, H stands for the height of it, which is the same thing as the altitude. So the distance around the base, whatever the shape is, times the height. The surface area is going to be the lateral surface area plus 2 times the area of the base. So we're getting all the lateral edges going around plus the top and the bottom. So once again, the lateral area is the perimeter of the base times the height, and then whatever the base is, you're going to find the area of that base. That capital B stands for the area of the base. Because we have 2 of them, you multiply it by 2. So let's take a look at our first example. What is the lateral surface area of the prism below? So we're just looking for the lateral area first and then the surface area second. So lateral area is equal to perimeter of the base times the height. So we need to identify the perimeter. That means we're going to add up the base as a triangular prism, so we have one side is 3, one side is 4, but we don't have the other side. So we can use, if we have a right triangle, we have 2 sides of it, we can use Pythagorean theorem to find our third. So 3 squared is, since this is the hypotenuse, it's going to be 3 squared is 9, 4 squared is 16, equals this side here. You add 9 and 16, get 25, and the square root of 25 is 5. You may recognize this as also a 3, 4, 5 right triangle. So we add 5 here. This gives us 12 for our perimeter. Now the height is the distance between our triangular bases, which means this is our height. So this is going to be 6. So the lateral area is going to be 12 times 6, which is 72. So this, we have centimeters, this is going to be centimeters squared. So 72 centimeters squared is our lateral area. So now let's take a look at our surface area. Surface area is going to be the lateral area, perimeter of the base times the height, plus 2 times the area of the base. So we've already established that the lateral area is 72, but we need to find the area of the base. Well, the base is a triangle, which means that we're going to be using 1/2 base times height. Now, the base times height is not the height of the prism. It is looking at our triangular face. So if we look at our triangle here, we have 3 on one side, 4 on the other, and 5 is the hypotenuse. So in this case, our base is 3, height is 4. So to find the area here, we're going to do 1/2 times 3 times 4, which gives us 12, and half of 12 is 6. So the area of the base is 6. So to find the surface area, now we'll plug our numbers in. We got 72 as our lateral surface area plus 2 times the area of the base. That gives us 72 plus 12, and that leaves us with 84 square centimeters as our surface area. So surface area is everything, including the lateral area plus the area of the 2 bases. All right, so let's take a look at part B. We're going to use the shaded in portion here, the gray side, as our base. Now you can, because it's in a rectangular prism, you can actually choose any of the sides to be your base. But you need to designate one so that you're using it throughout the whole entire problem. So right now, find the lateral surface area and the surface area of the prism below. Pause the video, come back and check to see how you did. All right, so let's take a look here. We have the base here, so we're going to get the perimeter, which is going to be the distance around it. So we can add our 2 side lengths and multiply it by 2, because this is 5, this will be 5 here, and this will be 4 up here. So 4 plus 5 is 9, 9 times 2 is 18. The height is the distance between our left and right, which is going to be 10. So multiply them together, the lateral area is equal to 18 times 10, which gives us 180 square centimeters. So the surface area is going to be the lateral area plus 2 times the area of the base. We know the lateral area to be the 180. So the area of the base is a rectangular shape, so that means we're going to use base times height. 4 times 5 gives us 20. So now we're going to plug it into our equation. 180 plus 2 times 20. So that's 180 plus 40, which gives us 220 square centimeters. All right, so let's take a look at this. What is the lateral surface area of the prism below? Now what we have is a hexagonal prism. We have a hexagon on the bottom. So the lateral surface area is going to be the perimeter of the base times the height. Well, perimeter of the base will be found by taking, if these all sides are the same, they're all 6. We have 6 sides, so it's going to be 6 times 6, which is equal to 36. The height is going to be the distance between our hexagonal bases, which means it's going to be 12. So height is 12. So lateral area is equal to 36 times 12. And 36 times 12 is going to give us 432. So lateral area is equal to 432 meters squared. The next part, it says, what is the area of the base in simplest radical form? Well, to remember the area of the base, we have to use 1/2 perimeter times apothem. Now we know the perimeter is going to be 36. The apothem we have to find. So we draw our center of this, draw the apothem, which goes, remember, perpendicular to the side. And now we'll find our angle here, reference angle, so that's going to be our half angle. Central angle is going to be 360 divided by 6, which is 60. Half angle right here is going to be 30. So that gives us a 30, 60, 90 right triangle. Now, if we know this side is 6, that means this half length is 3, which means the apothem is going to be 3 radical 3. So the apothem is 3 radical 3. So area of the base is equal to 1/2 of 36 times 3 radical 3. Now, 2 goes into 36 18 times, and 18 times the 3 is going to give us 54 radical 3. So that's our second answer. So that's the area of the base. Now, surface area is going to be the perimeter, or is the lateral surface area, which is going to be 432 plus 2 times the area of the base, which we know is 54 radical 3. So we get 432 plus 2 times 54 is going to be 108 radical 3. So the rest has to be done in our calculator because it says round to the nearest whole number. So we get our calculator out. 432 plus 108 radical 3. Nearest whole number is going to be 619. So surface area is 619. This would be meters squared. All right, let's look at our cylinders. A cylinder is a solid that has two congruent parallel bases that are circles. The altitude of the cylinder is the perpendicular segment that joins the planes of the two bases at a right angle. The height is a distance between our two bases, which is also the length of the altitude. Once again, with oblique cylinders, it's going to be that distance between our two circular bases, so that therefore it's going to be outside of our cylinder. So we have a formula here. Now once again, the formula is perimeter of the base times the height. Same formula for both, but the perimeter in a circle is the circumference. So 2 pi r is our circumference times the height. If they give you the diameter, pi times diameter times the height. We'll be using the top one the most, 2 pi r h. And then for the surface area, it's the lateral area plus 2 times the area of the base. Well, lateral area is 2 pi r h, and the area of the circle is 2 pi r squared. We have two of them, so it's multiplied by 2. So 2 pi r h plus 2 pi r squared. So the radius of the cylinder, radius of the base of a cylinder is 4 inches, and the height is 6. What is the lateral area and surface area of the cylinder in terms of pi? Since we're finding both, I'm going to write down my surface area equation, because my lateral area would be the first part, which is 2 pi r h, and then we're going to get 2 times pi r squared. Now the only variable we have here is two variables are the radius, which in this case is 4, and the height, which is 6. So the surface area is equal to 2 times pi times 4 times 6 plus 2 times pi times 4 squared. So we're going to write our answers in terms of pi, which means we're not going to calculate pi. So we do 2 times 4 is 8, 8 times 6 is 48, so we get 48 pi for our lateral area. And then we're going to add in 2 times the area of the base, which is pi r squared, so it's going to be 16 times 2, which is 32 pi. So once again, remember this is 16. 4 squared is 16 times 2 gives us 32 and pi. Since they both have pi, we can now add them. 48 and 32 is going to give us 80 pi. So this is our surface area. And these are in inches here, so this will be inches squared. The lateral area is going to be the part over here in the beginning, which is going to be 48 pi, which will be inches squared as well. So those are our two answers. Because the lateral area is used in the surface area formula, we'll just do the surface area and identify this as our lateral area. All right, so let's move to the next one. You guys work this one, pause the video, come back and check your answers when you're done. All right, so our surface area is equal to the lateral area plus 2 times the area of the base. Lateral area is the 2 pi r h plus 2 pi r squared. Now, we have a radius of 10, height of 9. 9 times 10 is 90, times 2 is 180. So that means the lateral area is 180 pi centimeters squared. Then, plug in our radius squared, which 10 squared is 100. 100 times 2 is 200, so we get 200 pi. 180 pi plus 200 pi gives us 380 pi centimeters squared.